Water scarcity in Kenya has been an issue for decades, as only a small percentage of the country's land is optimal for agriculture and the year-round climate is predominantly arid. The natural water resources also do not provide an equitable delivery of water to the various regions of the country. This in turn leaves most of the population without any fresh water. Rapid urbanization has also pushed poor urban dwellers to the slums, where there is no water or sanitation, and overcrowding exacerbates the already hazardous health conditions. The term water recycling is generally used synonymously with water reclamation and water reuse. Unbeknownst to most people, recycled water can satisfy most water demands as long as it is adequately treated to ensure water quality appropriate for the use. Since its incorporation in 2007, Water and Sanitation Professionals, WASP, a privately owned company, has constantly been advocating for the use of recycled water. And with over 70 systems throughout Eastern and Central Africa, the WASP system's ongoing research and development, coupled with a selection of leading international partners, allows them to develop and deliver suitable and site-specific privatized utilities such as wastewater treatment, sanitation and potable water solutions.
WASP Systems was formed to recognize a demand for sanitation solutions in East Africa and potable water solutions. We recently launched a very exciting project at Huruma Slum in Runda with UN Habitat and the Arthur Water Services Board, where we were providing drinking water for 3,600 slum dwellers, drawing water from a river, treating it, and then delivering it back in a World Health Organization standard.
While water recycling is a sustainable approach and can be cost-effective in the long term, the treatment of the wastewater for reuse and the installation of distribution systems can be initially expensive compared to such water supply alternatives as imported water or groundwater. However, the long-term implications of reliable water supply are a big advantage for the technology.
We provide sanitation solutions for rural domestic homes at a cost of about 40,000 shillings to replace the long drop with a safe sanitation solution. From that we go up to domestic homes with recycling of wastewater as well as potable water solutions for a home. For a classic domestic house, in order to take the water from their septic tank and put it back on their lawn, that would probably cost them around 350 to 400,000 shillings.
Treatment of wastewater is actually a simple process, as we discover, that utilizes very basic physical, biological and chemical principles to remove contaminants from water.
This is water from the flushing, from the hand wash basins. All the wastewater collected at one central point on an underground storage tank. We pump it into a series of tanks that you can see over here. These are bioreactors. They are fixed film bioreactors, and on each tank we aerate it. So this is an aeration process. It's a fixed film aeration process that we are employing in the wastewater treatment.
The use of mechanical or physical systems to treat wastewater is generally referred to as primary treatment, and use of biological processes to provide further treatment is referred to as secondary treatment. Advanced secondary treatment usually involves applying chemical systems in addition to biological ones, such as injecting chlorine to disinfect the water.
And after a series of about 7 tanks, 15,000 litre tanks, that's the storage capacity of each tank, we finally stabilize the treated water to get rid of any solids. That is what is commonly known as sludge. We collect all the sludge, which is activated sludge, full of nutrients. This can be sludge, you can use it as manure, but what we do is we use this manure back into the system, and the final product is clean, clear water.
More and more companies are adopting this technology to reuse their wastewater and improve the lands that surround them. One such example is Standard Chartered Bank, that opted for this kind of measure to easily manage their waste.
Since the installation of the plant in June 2011, we've seen a drastic reduction in the consumption of water, because in a day we use around 50,000 liters of potable water, and ever since the installation of the plant, the number has reduced to about 30,000 liters.
Another beneficiary of this is the Marist International College that adapted this waste system treatment and managed to transform their dry bare field into an open green carpeted grass area where local football teams meet for practice, and the grounds can even be booked for weddings and other functions.
We've had a lot of problems with our land behind us. You can see it behind here. But now with the plantation of the biobox, we have gained a lot because our land has somehow been reclaimed, as well as the wastewater that is being reclaimed here is being used for field grounds, irrigating the field.
Without a doubt, using recycled water of lower quality for purposes that don't necessarily require high quality of water saves energy and costs by reducing treatment requirements. Recycled water is most commonly used for non-drinking purposes such as agriculture, landscape, public parks and golf course irrigation. Advances in wastewater treatment and technology and health studies of indirect potable reuse have led many to predict that planned indirect potable reuse will soon become more common, and with unpredictable weather patterns, it is about time that Kenya adopted this technology sooner than later. As water demands and environmental needs grow, water recycling plays a critical role in our water supply. Along with water conservation and efficiency, it will help sustainably manage our vital water resources, while at the same time help save on costs brought about by food insecurity. Lizz Ntonjira, PM Live.